I, Dr. Abhay Kumar Sharma, son of Ramnath Sharma and Kumari Manju, village post Kamalpura, via Bakhra, district Muzaffarpur. Thesis submitted for the degree of Doctor of Philosophy in Physics under the supervision of Dr. Hajarilal Shah in 2004. Then, after examination, we get degree of Doctor of Philosophy. The topic of thesis is variation of capacitance and coupling between two coupled strip lines. Abstract. It is a well-known fact that long elements like resistor, inductors, capacitors, etc. are zero-dimensional system used for sending message signal using voltage and current concepts. Transmission lines are the two parallel wires, one-dimensional systems of communication using electrical powers in terms of voltage and current also. Strip lines and microstrip lines etc. are two-dimensional or planar system for communication using electromagnetic wave in megahertz and gigahertz range of frequency working in TEM or non-TEM modes. These systems also send messages in terms of electromagnetic waves. Waveguides, rectangular or cylindrical, are also three-dimensional system for communication using wave concept in microwave frequency range working in TE or TM modes of wave propagation. Nowadays, optical fiber is supposed to be the best and the most significant link for communication in higher gigahertz frequency range in the age of laser technology. This opened a new horizon of communication for one place to other far and unseen places. When two microstrip lines are placed together in close proximity, natural coupling exists between them. Such coupling exists in strip line and slot lines also, which are open in transverse direction. A section of coupled lines is used in various microwave circuits like directional coupler of given coupling coefficient and directivity, filters, independence transformer, circulators and insulators. Here we have to deal with the capacitance and coupling of the microstrip line coupled transmission structure and their variations with different parameters relating to the geometry of the structure and relative permittivity of the substrate along with the operating frequency in gigahertz range. The most important parameters which characterize a microstrip circuits are its characteristic, impedance, phase velocity, guide wavelength, etc. For the analysis of coupled microstrip line, the idea of even and odd mode propagation are used. In the present work, the characteristic impedance have been analytically studied in case of even and odd mode of propagation considering their dependence of the geometry of the structure. Relative permittivity, spacing between two strip lines, height of the substrate and the operating frequency. The scheme of the present work has been divided into five chapters. The first chapter relates to the general introduction, brief sketch of the work and importance of the work. The second chapter deals with the history and literature survey of the work and the important work done in the past on the planar transmission line structures. The third chapter presents the different methods of analysis for single and coupled microstrip lines. The present work in the thesis uses the computer-aided technique for the computation of the characteristic parameters of the microstrip line under in even and odd mode of propagation. The study of characteristic impedance of the microstrip coupler structure has been analytically discussed in chapter 4 in various sections outlined as the characteristic impedance for single microstrip lines is given by Z0 is equal to 1 upon VPCP, where Vp is equal to phase velocity of the wave traveling along the microstrip line and Cp is equal to capacitance per unit length of the line. Within permissible range of frequency in which TEM mode of propagation holds well, the result often have been placed in different tables. On the basis of these results, studies have been performed in the following section. Here we have concentrated our study for the calculation of the characteristic impedance and in variation in following section. Variation of characteristics impedance of coupled microstrip lines transmission with width. Variation of characteristic impedance of coupled structure spacing between two strip lines of the coupled structure. A study of variation of characteristic impedance for even and odd modes with relative permittivity of the substrate. Chapter 5 describes the study of capacitance for even and odd modes of the coupled structure and its coupling coefficients with their variation with microstrip geometries, substrate relative permittivity and spacing in the following sections. A study of variation of coupling coefficient of the coupled transmission structure with strip width. A study of variation of coupling coefficient with spacing between two strip lines of the coupled transmission structure, and a study of variation of coupling coefficient with relative permittivity of the substrate material used in the coupler. Now, with the importance of the work. The present work has its importance due to the following reasons. The present work has its importance due to the following reasons. The study is linked with the field of microwave integrated circuits. A significant advantage associated with the use of planar transmission technology at gigahertz range of frequency in that electromagnetic radiation originating from stars and other satellites object and study. Radar and satellite communication system also employ such technology. The importance also lies in the fact that microstrip the structures are small in size, light in weight, cheap and of greater relativity. Recent installation of microwave transmission links satellite communication channels and telephone communication likes all over the country and abroad have added greater significance to such work in the field of microwave. This field of work is generally related with the development of microelectronics, nanoelectronics, photonics, optical fiber communication, internet communication all over the world. Thank you.